A few days ago, I made a video on the different units of light and how they relate to each other, and I wanted to include guide number in that video, but it just didn't seem to fit, so it's getting its own video. Let's get undone.
Gerald undone. He's crazy.
Dinkum mighty, how many rotations do you need? I'm Gerald Undone, and today we're taking a closer look at the peculiar guide number used on flashes. Unlike the previous units we covered, and the reason why I omitted this from the last video, guide numbers aren't an exact measure of light power or intensity, but rather a formula based on distance. That formula is guide number equals F number times distance, typically expressed in meters, but some manufacturers will provide conversions for feet as well. So let's take a look at an example guide number, break down its parts, and then get into some of the misconceptions. So if we take the Canon 600EX, which is a popular speedlight, the guide number here is 60 meters or 197 feet at ISO 100 and when zoomed to 200 millimeters. So the first number is the distance, and with Canon speedlights and several other manufacturers, it's in the name. So the 600EX has a guide number of 60.0 meters, the 430EX 43.0 meters, and so on. And this distance is referring to the distance from the speedlight to the subject you're trying to illuminate. Now the other number, the 200 millimeters, is just telling you that this guide number only applies when the speedlight is fully zoomed, because many flashes can be zoomed just like lenses. The more zoomed in they are, the more focused and spotty the light beam becomes, and thus the more intense the light becomes on your subject. We're going to ignore this part from now on, but just keep in mind that when flashes have variable beam angles, they're usually rated for their most focused setting. Lastly, the ISO part is telling you that if you follow the other instructions, you should be able to get a sufficient exposure when your camera is set to ISO 100. And that sounds like enough information, right? And in fact, countless times I've heard sales pitches and advice that conclude the information there, basically suggesting that the Canon 600EX will illuminate a subject up to 60 meters away when you're set to ISO 100. But that's not true at all, and if we go back to our original formula, we can see why. So if guide number equals F number times distance, this could also be expressed as distance, or how far away our subject needs to be for us to light them well at ISO 100, equals guide number divided by f-stop. And so if our guide number is 60 meters, in order to also have a subject distance of 60 meters, our f-stop would have to be set to 1, and that's a pretty extreme f-stop. And it's also not up to 60 meters away, because ISO 100 is often the floor for cameras, so any closer and they'd be overexposed. So in order for that sales pitch from earlier to ring true, the rep would actually have to say, the Canon 600EX can light your subject well at full power when your subject is exactly 60 meters away, and your camera is set to ISO 100, and you're using an f1 lens, and the flash is fully zoomed. That sounds a lot less impressive now, doesn't it? But it is more useful because now we know exactly how to distance our subject. All you have to do is substitute in the actual f-stop you want to be shooting at. So say you wanted to use f4. Well, with a guide number of 60 divided by f4 equals 15 meters. So at f4, with your subject 15 meters away, at ISO 100, at full power on the flash, your subject should be well exposed. But remember, the 60 in that equation came from the Canon 600EX, and the guide number is likely to change depending on whatever flash you're using. And if you're going to use feet as a measurement, make sure you use it at both sides of the equation. So here's another example using a different light and using feet. The Canon 430EX has a guide number of 43 meters, so 141 feet. And if you wanted to shoot at f2.8, how far away would the subject need to be? Well, 141 feet divided by 2.8 equals 50.4 feet. So if your subject was 50.4 feet away and you were at f2.8 and your 43 guide number flash was at full power, you should get a decent exposure. Easy enough, right? But what if you wanted to move the subject closer? Well, you'd have to lower the power of your flash, but the relationship here isn't as easy as it might seem, and that's when we get into our second misconception. In our 60 meter guide number example, we said that when shooting at f4, your subject would ideally be placed 15 meters away. But what if we wanted to bring our subject to 7.5 meters away? Would we reduce to half power because half of 15 meters is 7.5 meters? Unfortunately, no. That would be easy, but it would ignore the inverse square law, which basically suggests that as the distance doubles, the light intensity decreases by 4 times, not 2 times. So you'd have to take your flash power, which is usually expressed as a fraction, and find the square root of it. So in our example of half power, the square root of 1/2, or 0.5, is 0.7 rounded. And so then you would take that and multiply it by your distance, 15 meters, which would be 10.6 meters, not 7.5 meters. And so in this case, at half power at f4 with a guide number 60 meter flash, at ISO 100, you would want to place your subject 10.6 meters away. Okay, so now that we understand a couple of the misconceptions and the correct math, how do we apply this to practical situations? Because let's face it, we're not likely to figure out the power first and then place our subject that far away, but instead, typically you would frame up a shot that you like and then figure out how to light it well. So typically the distance would come first and then the power would come after. But the problem is this whole system is based on the idea that you'll just stop down your aperture in order to get the correct exposure. So if you're using a flash with a guide number of 48 and your subject is 6 meters away, well, you'd have to stop down to f8. 48 divided by 6 equals 8. And then you'll get a good exposure. But what if you want to use a particular f-stop and want to know what power to set? Well, unfortunately, this information is much harder to find. And in fact, many of the calculators online generally only solve for aperture and distance, but not flash power. And the reason for this is logical, because the power of your flash isn't tunable to a precise degree and is instead forced to exist within the confines of specific fractions, all of which are powers of 2. And so if you were to put a random distance, guide number, and f-stop into a calculator, the solution might not, and likely will not, match one of those particular available fractions. But there is a way to figure this out using our previous conclusions, and you can do this on the fly as long as you know your f-stops. Let me give you an example, and let's use our guide number of 48 again. But this time, let's suggest that we want to photograph a subject that's exactly 1.5 meters away, which is probably more realistic than 15 meters. And let's also suggest that we want to use an f-stop of 2.8. How do we figure out what power to set our flash in our head without memorizing another formula? All we have to do is figure out our f-stop at full power and then move the same amount of stops on our flash as we would on our camera. So if you remember back to the beginning when I said the guide number equals f-stop times distance, well, if our guide number is 48 and our distance is 1.5 meters, then our full power f-stop would be f32. 48 divided by 1.5 equals f32. And so if we know that our full power f-stop is f32, what power do we need at f2.8? Well, luckily, every stop of aperture is equal to a stop of power on the flash. And so if we go from f32 down to f22 on our camera, we would go from 1 over 1, or full power, down to 1 over 2, or half power, on our flash. And then the next stop, from f22 down to f16, would take us from half power down to a quarter power. And this would continue all the way down to f2.8, which would tell us that our flash power needs to be set to 1 over 128. And if you know your powers of 2, this gets even easier, because all you have to do is count the amount of stops that you moved and make that an exponent of 2. So to go from f32 down to f2.8, that's 7 stops. And so 2 to the power of 7 is 128. And then you make that the denominator in the flash power, so 1 over 128 power. If you move 5 stops, 2 to the power of 5 is 32, 1 over 32 power. And you only actually have to memorize up to 2 to the power of 7 because most flashes have 1 over 128 as their lowest power setting. And here's a trick to memorize your f-stops while you're at it. As long as you know 2 f-stops that are side by side, you can figure out the rest of them just by doubling them in pairs. So if you know f2.8 and f4, then you can figure out the rest because doubling f2.8 and f4 will get you to 5.6 and f8, and then double those, f11 and f16, and then double those, f22 and f32. But if you suck at memorizing things and you hate numbers, there's an even easier way. You can actually physically move the dials for your camera's aperture and the flash power in the same increments. And this even works in 1/3 of stop increments because 1/3 of a stop in f-stop is equal to 1/3 of a stop in flash power. So you basically just move the correct amount of stops to get you down to the f-stop that you want, and then move the same amount of stops on your flash power, and you'll be set up correctly. Now up to this point, everything has been based on ISO 100, but what happens if you increase your ISO? Well, increases to ISO also increase the effective guide number, but you again have to respect the inverse square law. Essentially, quadrupling the ISO is equal to doubling the guide number. So if you're working with ISO 100 with a guide number of 48, then if you moved up to ISO 400, the guide number would go to 96. Every time you multiply your ISO by 4, you multiply your guide number by 2. I also have a quick note on the last element of exposure, shutter speed, which will also tackle another misconception. You probably noticed that shutter speed wasn't in any of our calculations, and that's because shutter speed does not affect the amount of illumination on your subject from the flash. The light from the flash is provided at the same interval that the photo was taken, so exposure time is kind of irrelevant. Shutter speed will still affect the amount of ambient light collected though, just not the flash's light. So that's it. That's all the wonky math about guide numbers. The idea behind this video was to clear up some of the misconceptions, but also provide a practical use for some of these numbers so that you can get the correct exposure every time. And I think for someone just starting out in flash photography, this is a great place to begin and a great thing to learn. But there is a missing factor here that I should mention to tip my cap to the veterans of using flash. You get to know your flashes, and this is doubly true if you have a studio. While I do think that my stop for stop method is about as convenient as it can get for calculating multiple lighting variables, doing the math will still be slower than a pro who just knows their lights. And if you're just starting out, don't worry, you'll get there too. Eventually you'll just know that a quarter power is the right answer for that situation. But in the meantime, hopefully this video will help prevent you from taking too many test shots while you get to know your lights. But that's going to be it for me. I hope you found this video helpful or at least entertaining. And if you did, make sure you leave it the old thumbs up and consider subscribing if you haven't already. But if you did not find this video helpful or entertaining, feel free to hit the dislike button twice. Alright, I'm done.